Okay, so I'm now going to introduce you to the three bodies of research in the cognitive neuroscience of combinatory syntax and semantics that I mentioned earlier. So violation studies, hemodynamic research on Broca's area, and research on basic composition. And so today we're going to start with the violation studies. All right, so this body of research asks the question of what happens in your brain if the incoming stimulus violates your knowledge about your language in some way. So in your brain, you have lots of knowledge about the grammatical properties of your language, the semantic properties of your language. Exactly how does your brain respond when the stimulus does not fit that knowledge? There's something wrong with the stimulus. That's the basic idea behind the violation studies. So armed with a technique that gives you a very detailed temporal resolution like EEG or MEG, so we have millisecond time resolution, we can ask the question of exactly how quickly after the onset of the critical stimulus, so usually that's like the offending stimulus, the stimulus that violates your knowledge, exactly how quickly does your brain respond to that, that violation. And so here, I'm plotting an imagined electrophysiological response where at some point the brain kind of notices that, oh, there's something wrong with the stimulus. And so then also armed with theories about different types of knowledge about language, we can ask the question of whether the brain discriminates between these different types of knowledge. So we can manipulate the properties of the stimulus and ask whether one type of knowledge perhaps elicits a faster response than another type of knowledge. So does your brain respond differently to violations of different types of knowledge? So here we have like one type of knowledge giving you a really quick response, maybe a slightly slower response to another type of violation, and maybe an even slower response to a third type of violation. Okay, so now keep in mind that we've talked about three different types of knowledge that guide the construction of sentence structure. So how words combine syntactically, how words combine semantically, and then of course your knowledge about the world very much guides the way we construct language and also how we perceive it. So much of the early EEG research using the violation paradigm was relying on research that was coming from theoretical linguistics in order to vary the stimuli syntactically in several different ways. So basically, instead of just contrasting syntactic knowledge, semantic knowledge, and world knowledge, they varied syntactic knowledge in multiple different ways. And so one of the seminal studies doing this, it was an experiment by Helen Neville, Janet Nicol, and colleagues, where they did exactly this type of manipulation where there were multiple different types of syntactic violations. And similarly, Angela Friederici's group in Germany conducted a large body of research using the same methodology. So several different types of syntactic violations, asking the question of exactly how does your brain discriminate between them. And here's a picture of Friederici's model from 2002. There's been lots of subsequent versions of that, but this paper is sort of the first real comprehensive culmination of that body of work. So I now want to give you a bit of an idea, a bit of an introduction to the main outcomes from this research. Like what should we know about this body of work? Well, what we learned from this body of work is that in these violation studies, violations seem to kind of come in three different stages. And so this is primarily a summary of the Friederici style model. So let's imagine, so here are my cartoon three stages. What's the earliest stage? It happens pretty quickly. So starting around 150 milliseconds, 250 milliseconds. This stage is hypothesized to be associated with your knowledge about how syntactic categories combine. So the violations that elicit this the quickest response are phrase structure violations. So violations of how the syntactic categories of your language go together. So syntactic categories being like nouns, adjectives, adverbs. The phrase structure rules of your language tell you how to combine them together. Like in your language, does the adjective come before the noun like it does in English, or does it actually come after the noun like it does in, say, Spanish? So that's what we mean by phrase structure rules. And so here's one of the kind of classic contrast. So this is actually from Neville et al. So here we're violating the phrase structure rules of English. The red of is the violation. So the scientists saw Max's of proof of the theorem. So at of, you're violating the syntax of the language. After Max's, you really want to get a noun because it's you just named a possessor. You want to get a noun, but here you instead get a preposition, and that your brain is like very quick to notice. And so in these experiments, then this violation condition would be compared to a well-formed control condition where you would also have that same item, but now in a position where it belongs, where it does not violate your knowledge. Like the scientists saw Max's proof of the theorem. And then we would do an analysis of contrasting the two ofs. And what was discovered is that that's actually something that your brain can spot really, really quickly. Okay, so that's the first stage. Then there's a second stage at which syntactic knowledge of a slightly different sort seems to come to play. So now this is knowledge about case and agreement. So English is not a great language for explaining case because we have a very impoverished overt case system. So most of the time you can't really hear case, but we can hear it in the pronoun system. So I saw him has, is overtly in the accusative case, whereas if you say he saw me, then you sort of see the phonological difference between he and him. So that's what we mean by case. If you studied a language that has a richer case system in the phonological component, meaning like you can actually hear it, then that's quite intuitive. But we can construct these contrast in English as well, as long as we use the pronoun system. So here's a case violation. The plane took we to paradise and back. So here we is occurring in the nominative case, whereas it really should be in the accusative case. So accusative is expected, nominative is encountered. And that's the type of violation that in the Friederici model has a kind of a mid-latency effect. Similarly, agreement violations like the elected officials. So now you need to have a plural verb, which in English would be hope. But if you do hopes, which is the singular form, that elicits a similar kind of mid-latency response. So here, plural is expected, singular is encountered. So here, the types of syntactic features that have this mid-latency timing are more cases where you have to sort of compute relations between items in an expression, as opposed to just looking at local phrase structure. Okay, so that's the mid-latency time window. And then we have this late stage of processing. And this is thought to relate to some type of reanalysis. And by reanalysis, I mean situations where you're computing the structure of the sentence and you're happily going along, and then you get an item that changes the analysis. Like you have to change the structure that you already computed. So let me show you an example that will make that more intuitive. So these are so-called garden path expressions. You may have heard that term. So if I say to you, the judge believed the defendant, you're going to be like, okay, the judge believed the defendant. That's cool. You think the defendant is the object of the verb believe, but this could actually continue like this. So the judge believed the defendant was lying. If the sentence continues that way, you actually have to scrap the analysis of the defendant as the direct object of belief, because it turns out that this whole sentence is the direct object. So the thing that is believed is that the defendant was lying. And you notice that if we put that over that here, then the sentence is disambiguated. So the judge believed that the defendant was lying. So if you hit this kind of an item like was here, I've highlighted it in red, that is making you change the analysis that you had ongoing, then that elicits this a little bit more sustained, kind of like a longer lasting late effect. So the defendant is here analyzed first as the object, but then was forces you to reanalyze it as the subject of the subsequent sentence. Okay. All right, but now, so all of these effects have names associated with them. So the first type of effect is called the ELAN. This is the early left anterior negativity. That tells us something about the scalp distribution of the effect as measured by EEG. So this says that this effect is recorded most prominently from electrodes that are on the left side of the EG cap, and it's a relatively, and it's a negativity. That's what I'm trying to say. So it's the violation condition is eliciting a stronger negativity than the well-formed control condition. So that's the first response. The second one is just the same except without the E, so it's the left anterior negativity, so it's also negativity. It's just not quite as early. You can imagine that you can get into situations where these are a little bit hard to tell, that it's hard to tell the difference between the two, and that's certainly been a conversation in the literature. And then finally, we have the P600, that's the reanalysis component, and that just refers to the fact that it's not a negativity like the other two guys, but it's a positivity, and it peaks around 600 milliseconds. So here we have that, the timing in the label of the component. But now we don't want to leave this timeline before remembering that we have learned about another very consistent EG fact that is a response to an unpredictable item, something that certainly violates your expectations, and in this original example also violates your knowledge about the world. So very surprising, anomalous, he spread the warm bread with socks, elicited the largest N400 response, and then the very predictable control condition, he spread the warm bread with butter, gives you this much smaller amplitude. And so this early discovery was definitely part of the slightly later models as well. And so, for example, in the Friederici model, the mid stage of processing is associated both with the LAN and the N400. Okay, so here, what I have on this tier is these three different types of syntactic knowledge or processing. So something about the phrase categories, the phrase structure of your language, the syntactic categories, how they combine. Then we have knowledge about case and agreement, so a slightly different type of syntactic knowledge, and then this kind of later stage of reanalysis if things kind of go wrong at a certain point in processing. And then when we talk about the N400, then in terms of the types of knowledge that I've talked about so far, here the violation has to do with your world knowledge. So the original Kudus and Hilliard example has a meaning that just is, you can compute it, you can figure out what that sentence would mean, but it just doesn't match your world knowledge. What about the more kind of linguistic semantic knowledge? So the semantic knowledge that you have about your language that does not sort of reduce to world knowledge. What does the violation literature say about that? Well, it actually does not say very much. So here we have very few violation studies that have really manipulated the kind of logical semantic properties of linguistic expressions in a way that would be inspired by the formal semantics literature that arises from theoretical linguistics. There is a little bit of work on that. And so I'll show you one example, a study that I did over 10 years ago now. I do want to give you a little bit of a warning, and that is that the word semantic and semantics is used very differently in different subfields. So when linguists say semantics, we are talking about the linguistic semantic properties of expressions that are not world knowledge. And so in the earlier video, I gave you an example of these concealed questions. I'll give you another example in just a sec. But that's how linguists use that term. In a lot of the cognitive neuroscience of language, semantics is often actually semantics often actually refers to world knowledge. So in many experiments, you might have a world knowledge contrast, but that is labeled as a semantic manipulation. Okay, so just different conventions in different fields. And then further, there's a use of the term semantics that really kind of refers to your conceptual knowledge. So there's a more of a lexical level body of work, again, in the cognitive neuroscience of language, but also just in psychology, where semantics really means, refers to divisions between conceptual categories, like living things versus non-living things, tools versus animals, these kinds of distinctions. So you have to be a little bit careful with that term and just be aware that the different fields use it differently. Okay, with that caveat in mind, let's just take a quick peek at this study that we did quite a long time ago, where we really aimed to contrast directly your knowledge of semantics and of world knowledge in this type of violation paradigm. And our aim actually was to connect our non-violation work on semantic processing defined in the kind of linguistic way to the violation body of work that was the sort of the dominant paradigm at the time. Okay, so here's what we did. And so now this gets a little more complicated because we're getting into those kind of logical properties of the semantic system as opposed to just something that we can introspect about our world knowledge. So we took advantage of the semantic constraints on verbal unprefixation, okay? So let's look at some examples. So the prefix on, when you put it on verbs, it has a generally reversative meaning. So if I say, I unbutton my jacket, what I'm saying is that I undid the result of buttoning my jacket, or I undid the result of my jacket being buttoned, okay? It clearly doesn't mean I didn't button my jacket. So the adjectival on has a kind of a straightforwardly negative meaning. So I am unhealthy pretty much means I am not healthy. That's the meaning of the verbal on is different. So that's already kind of interesting. So I unbuttoned my jacket, I unbraided my hair, I undid the result of having braided my hair or my hair having been braided. Okay. But on has a lot of kind of interesting restrictions that are not obvious. So I unleft for work. Not a great sentence to say, even if you can kind of imagine a situation where I'm like leaving my work and I'm at the leaving for work and I'm at the elevator and I notice that, oh, I don't have my keys. Maybe I have to go back and pick up the keys. And then I'm just like, screw it, I'm not even going. Like that could be an unleaving for work. But it's really, that's just, there's something wrong with the sentence. Doesn't work very well. Similarly, I unflushed the toilet. Really unclear what that would mean. I unswitched the light bulb. These are really hard to interpret. And unlike the typical world knowledge violations, you kind of have this intuition that it's hard to even know what this would mean. So it's kind of like your semantic combinatory system isn't working the way it's supposed to be working, which is very different from, you know, I buttered my bread with socks, where you can imagine like, oh, if you have the socks and you're using it as some kind of a spread and so forth, like your semantic combinatory machinery operates and then yields this anomalous meaning. These are cases where it's like, I don't feel like I got a meaning even. Okay, so why is that? Well, it's because of these semantic restrictions that un has that you have to kind of study in order to even realize. So it turns out that the verbal un, it wants its verbal stem, so the verb that it attaches to describe an event that has, first of all, what we call a complex event structure. So it has to have the event has to have a structure where there's kind of a process that leads to a result. It's called an accomplishment verb. So for example, leave, so on left, it's kind of like it doesn't have quite the event structure that on wants. And also on describes actions. The un wants to have verbal stems that describe actions that put something into a more marked or specialized state. This is like a really specific restriction, but you can kind of see that with the examples. I unbuttoned my jacket, I unbraided my hair. So braiding, you know, creates this configuration that you could consider like a marked configuration that then is released when you attach on to braid. Buttoning is a marked configuration that can be released by attaching on. So the main point is that un has these restrictions that are more linguistic, not just your world knowledge. So we took advantage of these restrictions and constructed an experiment. We contrasted violations of these restrictions. So we gave the subjects these unswitched the light bulb type expressions and contrasted those violations with the usual type of world knowledge violations that you know, were common in the literature, specifically asking the question of whether we could observe distinct neural correlates of the two. And in fact, we did. So in ventromedial prefrontal cortex, so here I'm showing you the kind of bottom of the brain. So if I went like this, so the very bottom surface of the brain, in medial cortex, there was a response that we actually had already identified earlier when we were studying purely well-formed language that responded to these semantic violations, but did not respond to the world knowledge violations. So we were able to observe some kind of correlates, neural correlates that may have been unique to the semantic violations. Here we can kind of get an idea of the timing of that. So we're more like in the 250 to 300 milliseconds time window. So like a little earlier than the N400 time. So like I said, not a lot of studies that try to do this, but I'm just kind of tentatively putting that on our timeline here. And we can return to that when we talk about research where semantic composition is varied within fully well-formed expressions. Okay, so let's summarize. So this violation approach has been a very popular approach for studying the brain's sensitivity to different types of linguistic knowledge. It is not as popular anymore as it used to, but if you don't know anything about this body of work, it's really hard to make sense of the current literature. It's a very important component of kind of what's happened in our field. This approach can yield valuable information about how serial or parallel processing is. So here I've shown you a picture that has kind of a serial character, at least there's some different stages. All of those stages are debated. There's a lot of research asking to what extent exactly, things really are that serial, but, that type of information is very much a kind of a core component of this approach. So now there is a very large literature that investigates the role of prediction in these violation effects. And so here, I haven't really explicitly talked about it, but each of the violation effects could be elicited by your brain computing the structure that, trying to compute the structure that then ultimately does not converge. So there's a violation of your knowledge, but then you kind of fail to build the necessary structure. That's a different type of explanation from an explanation where you're really strongly expecting a particular item and then you don't get it. So the question is whether any particular violation effect reflects the ill-formedness of the expression, or that you were strongly expecting something else. And so, for example, for that early effect, the elan, we know that it largely goes away if the offending category, so the category that does not fit the grammar, doesn't also violate a prediction. And there's a beautiful study by Ellen Lau and colleagues that kind of showed that for the first time. Similarly, for the N400, we have for a long time known that it very strongly reflects prediction, so the predictability of the word. Like socks being very unpredictable in that classic Kudus and Hilliard example, but exactly figuring out how much of the effect is due to the unpredictability of the item versus the implausibility of the resulting meaning has been somewhat unclear and sort of a topic of debate for, at this point, decades. What I'm citing here is a large-scale, very recent study by Montanoilan and colleagues, where they show that with a kind of a naturalistic stimulus and a big sample, is that the N400 primarily reflects the predictability of the word. So the plausibility component may have been part of the prior results, but when you tease the two apart, plausibility actually has a rather different type of effect and a slightly later effect. So that's kind of like just a quick summary of where that literature has gone. When we think about the violation research, we always want to keep in mind that effects of violations may not actually reflect processing that happens when we're constructing or analyzing completely well-formed sort of normal language. So it could be the case that your brain responds to violations differently from the way it responds to just completely well-formed language. So what I mean is that the violation effects may not be modulations of the normal types of activities, they could be special. So that's a research question that has been addressed for many of these components, but that's is a limitation of this approach. So ultimately, to uncover the neural basis of syntax semantics, we do want to vary the syntactic and semantic properties of completely well-formed expressions, so the kind of language that we actually deal with in our everyday use of language. And that's what we'll turn to next.